Welcome back. Today we are going to understand how the Android application runs on Android OS. I'm very curious to understand how things work because I remember 10 years ago when I started first time Android development. I'm amazed when I saw the toast. First is a toast, and the second one is I'm amazed. I asked the question, where is the main method? Because I'm coming from C++ and Java, and every time when I create a project, there is always a main method. And I asked that question to myself, to my curiosity, okay, where is the main method? And later I understand, okay, what is manifest? And it took some time to understand, but one day I figure it out. There is a main method in Android as well, but it's like internally called. So today we are going to understand that. Hopefully we will figure it out that. The second thing is, again, I'm not expert with the internal implementations of Android OS. So maybe the file which I found, I'm showing you, that may be wrong one, but still it's okay. We will learn something new. So I already created a app. So we are going to start from here. By the way, also I open these two websites which will help us. One is developer.android and the other one is Android code search, which is basically Android OS code, and we will be here. Okay, so we are going to start from on create. So who is calling on create? So mainly there are multiple classes. System UI application. Okay, it looks like it's internal base class for maintaining global application state. You can provide your own implementation by creating a subclass and specifying the fully qualified name. The application class or your subclass of the application class and before. I think it's not related to us. It's system UI application means the internal uh, OS, some kind of an APK which is already part of a system image, but it's not related to our app. So we can go back and then check theme resolver, a resolver to resolve the theme from a string or activity. Okay, so they are only using this package installer. Oh, nice. Okay, so it look like again they have an internal APK. I think so. It's part of a system image package installer APK, but we are not looking for this. So going back, then, but by the way, yeah, if you jump in, you figure it out something, you are interested, you are curious, jump in and go into details because it's a rabbit hole. Every time when I open that, I start thinking something else, and suddenly I found, okay, after 10 minutes I'm doing something else, but I'm looking for uh, topic A, but now I'm in a topic B. So you can jump in, it's okay. Strict mode, mm, um, look like right what we're looking for. Setting injector service to ensure a good user experience. Okay, so there are these. I understand this class. This one is pretty important class, and this one, so instrumentation dot app dot android. So it's saying call application on create. Perform calling of the application on create method. The default implementation simply calls through to that method. No, this method will be called immediately after on create bundle. Often instrumentation tests start their test. Okay, first we will see what is this class instrumentation. So base class for implementing application instrumentation code. When running with instrumentation turned on, this class will be instantiated for you before any of the application code. Allow you to monitor all of the instructions. It look like it when we are doing, I think so, testing, a UI testing, most probably at that time we used instrumentation, and it looked like that is maybe this is the class, not sure. Okay, but going back, and then activity thread. So activity thread, it's running now. We need to figure it out first. Okay, maybe first we will discuss what is an activity thread class. So this manages the execution of the main thread in an application process. So all the applications have their own process. If you are not sharing, if you are sharing the process, then it's again different story, but for now we are assuming every application has their own process. And in that process, when we run the activity, start surveys, broadcast, not, I think so, broadcast also, because I did some days ago, I worked on this class, and I found this class is pretty kind of a core. It is used for running activities, and it looked like, to me it looked like it's maybe runs one after the zygote or at a kernel level. I don't think so it's specific to a one application process, because we will see how we are using the implementation in between. So we are going back and then going back into the activity thread. So it's saying, okay, this is the called, and here we are initializing this from the context package info, some information. So now, and also we have instrumentation initialized here, but now we can check. Okay, this is an application, makes sense. Exit application, terminate current application, get application, resolve. I think we can go back and then click again, and now we can search this method, like at what time this is calling. So it means once we click on a icon, somehow at some time when the process is ready, Zygote created a process is ready, and I will say, I think I'm using wrong terminology. Zygote process is ready, and it's coming to this, and then it's getting the application class which we have. Like it depends, every application have their own class, maybe there is no implementation of class, and then it's saying okay on create, and then this on create call. So I think from here we can go back to understand more. So don't set application object here. If the system crashes, if the system crashes, we can't display an alert. Okay, nice. So again we found a good comment. Mm, so going up. Okay, so this is the method which is called attach, and who is calling this? So there are two methods. First we can check this. So system main, and what about the other one? So other one is called main. Oh, nice. So yeah, so I so now you can see in Android we have a main method, and then OS will run that, and then after that, I'm not sure if it's only runs once when the we boot the reload restart the OS, or the once the we turn on the OS, or it runs for every application. I have a feeling it's one time when the boot completed, but it's okay. Then okay, the method is one is we found. Okay, we can read this one also. So what is saying? Okay, saying install selective syscall interception android os dot install. What is this? It's android os extends forwarding os, and I have no idea. Android, what is android os class? Maybe we can read this. So install selective system call interception. For example, this is used to implement special file system path. Not easy for me to understand for now. Okay, we can go next. After that, once this is done, there are some initializations. Then it's saying okay, call per process mainline module initialization looper. Okay, so as you guys, I'm sure if you are developing the Android application, you know we have a one main thread which is called UI thread. Basically there are two threads, one is a UI thread, the other one is a rendering thread. So looper is the queue architecture, where we have a one queue. Every time when you do something on it will send a message, and that message is on your queue, and that is called also main thread, and that is an prepare main looper. So you can read this class. This one is pretty simple. So here we generate, then after that this is the activity thread. Okay, we initialize this, then we are calling this thread dot attach, and it means activity thread is going to be attached and systems false. So I think we started from this method. So activity thread is attached with this one. Yes, we started from this else. Okay, once what is the condition of if and else? Okay, if system is true, it will be false, then it's going into the else. If system is false, it making that is true and going inside of this, and then doing some work. Okay, then handle. Okay, we can try to go more back in this one. So this one is called here, and in this case we saw main method. Then also we saw, so who is calling this main? It's not easy to figure it out. but still it's okay. So system main, okay, then this one is also one more method. And who is calling this? I think. And then after that we are also doing init for system process, and this is thread renderer. Then we are creating this activity thread and then attaching this. So I think this one is important. So we can come here, we can check who is called. So this method is available inside of activity thread, yes. So you can click activity thread, it will directly open that. And once you click, it will show who is calling this method. So we can see this is definition annotated, this is a call hierarchy. So there are three basically framework classes. One is USB command, telecom, system server. I have no idea what are these classes. So USB command, what is USB command? So USB command class, okay. So there is no documentation, but you can read. And I'm going back. So you telecom, what is telecom? So in case of a telecom, first we will see what is a telecom class. So command line entry point. Okay, one more main method, initialize the telephony module. And initialize the telephony module, I think so the dialer and and there is a lot of information, but it looks like it's specific to this. And then we can go to the system server, it look like this one which we are looking for maybe. So it's saying okay, create system context and system server dot java. We can check if we can access this here. Okay, it's available here, and the method name is create context. So this is the method, and this one is called from here. Okay, this one is a private method which is run. Who is calling this run? Okay, we can go back to this first. We can read a little bit. So in this case, things are going on. Anything uh, SQLite, sync mode full, no idea. Clear growth limit, more memory, okay. Ensure fingerprint properties. Some devices rely on runtime fingerprint generation, so make sure we have defined it before booting further within the system server. Nice information available here. Then initialize native services. Allow heap perfect profiling. I need zygote child heap profiling. So and we are here from this, yes. So this method is called here. There's a lot of informations. Activity thread, again the same class, mainline module initializing. Then what else? Local service. Okay, if this is debuggable, then what they are doing. And then there is a looper dot loop, so it's going to start a loop. Okay, now we can go up from where things are starting. So this run, who is calling this run method? So again there is a one more main entry point from zygote. So there is a zygote, I think so, that process is calling this somehow, I don't know, but it looks good. Okay, so system server, and what system server is, okay, it's doing some. So any documentation, entry point to system server. So we also found one more point at that point. Then activity thread. So again coming back from here, who called this, we found activity thread. Then activity, in activity thread we found this. And here we are creating the application context, then assigning that. And there are two path. If it's from system, then it's going inside, if not, then going outside. And then we saw who is calling this. So this is called from two places, one is a system main and the other one is a direct void main. And if I am not wrong. There is also loaded APK class which I found, and what this will do, so local state maintained about a currently loaded APK. So I think once we click on an application icon, it it will, once it's the process is there, it's saving that information, loaded APK information, and we can see activity thread, package name, application info. So most of them we already aware of these fields, application. Then we can read some what kind of design patterns they are using. Okay, there are receivers, array map, context. Then it's nested array map, which is has a broadcast receiver, receiver dispatcher, loaded APK, array map. Then log loaded APK. Okay, so create information about a new APK. Not this constructor is called with activity thread logs held, so must not call back out to the activity manager. So at this place, when this is called, so who is calling this method? Okay, so loaded APK somehow get package info. Nice. So once there is an information this method, then it's checking user ID, synchronize resource manager, weak reference, caching not supported across users. Okay, makes sense. Then we are getting this reference not equal to null, then get if not null, then we are doing some work here. If it's in case of null, okay, then they are returning from here, but in case of null, it's coming here, and then it call the constructor. Then we have this information. It's our system application info and system thread not equals to package name, different user. Nice. But now we can check who is calling this method. So it's again coming from the activity thread, and this one is init instrumentation. I'm not again 100% sure, is it only this one is called from for testing only, or is there any other reason? Okay, we can see if there is any information. So what is this method? Wow, pretty long. Handle by application. Also you can see the rules, the the code classes or code methods, but it's amazing. Okay, handle by application, register the UI thread as a sensitive thread to the runtime. Something is going on. Then anything which we really know, compared callbacks, no idea. Configuration controller, I think this one we remember we discussed, I think in last video. The process level configuration changes when the device and all related things is managed by this class, I think so. Profiler, which profiler is this? Process package name, set process directory, target SDK. Supply the target SDK to the UI rendering module, which may need it in cases where it does not have access to the app info. Okay, so we can move towards this, but I'm not interested for now. So no need to go towards graphics. Okay, before spawning a new process, reset the time zone to be the system time zone. This needs to be done because the system time zone could have changed after the spawning of this process. Without doing this, process would have the incorrect system time zone. Okay, so time zone is going to, we are going to set this. What is the name of this method? Okay, handle bind application. By the way, we can check who is calling this. So this one, handle message. Handle message means the main thread is sending a message, and with the bind application. What's next, where we are? Time zone, then font map, synchronize resource, update the system configuration. Okay, anything which we are aware of. So this one is looks something we know. Switch this process to density compatibility mode if needed. Application overflow support, screen densities. Okay, nice. So is only updated from the main thread, while this function is only called from main thread as well, so no need to log here. Okay, so they are saying no need to log here, the developer. But what they are doing, okay, they are checking use 24-hour setting, core settings. So okay, then it's 20. You remember, like we saw, they are trying to set the time zone again for this process. Then they are checking, okay, 24 dot equals true if true or false is 24-hour. Okay, then null use locale default 12-hour format. Okay, nice. Strict mode and it's thread default. Okay, so I remember when we are debugging, when we are running application as a debug mode, that can crash if we have enable this. So they are initializing at this point in this method. Then debug off if it's on. Then what they do, debug dot. Okay, nice. So if you run the app with the debugger on Android, I think you can see this dialog. It sometimes it's showing the dialog with the message, waiting for the debugger port 8100, and then this is also message shown on a console. And once the debugger is attached, they are saying okay, it can be debug port. Nice. We found some information which we are aware of. Okay, allow binder tracing and application generated system messages. So I think this one, to me it look like these are the all those flags which we enable in a manifest file. So in a manifest we have an application, and in application we saw debuggable true or false. If it's debuggable true, then do this and this. Then hardware rendering, allow rendering feature if so I think that one is also come from the package name. So we are setting package name. Then any other. So now at this point we are going to create a context. Locale list from app context. Once this context is ready, what happened, trace begin, pre-boot mode, binder, we have a service, connectivity manager, get this, we have this service. Then they have some kind of a proxy which is settled down. Then trace end, and it looks nice. They most probably they have some kind of a matrix in Google, and they are checking if there is any regression. It looks really amazing, where they are getting this data. It's beautiful. Okay, then process dot, because this one is like, I have a feeling it most probably it's 2 billion 2 billion devices. So amazing. Okay, so process dot is isolated. I have no idea. um, Anything which we know otherwise. Okay, here they are initializing instrumentation. If I not equal to null, then do this init instrumentation, otherwise. But in both cases they are going to create a new instrumentation. Oh, nice. So this one, if you guys remember, I remember some years ago, I have a one app which is around graphics. So we are playing with the images, and mostly app crashed due to the out of memory. And I found, okay, there is a one flag in Android manifest file, large heap, you need to do true, and after start working. And this one, I have a feeling, again it's my understanding, here checking once they are running here. Okay, if the application info large heap, I think so it's true. Maybe clear growth limit, it look like they are giving me the more heap. And else if we are not doing that, small heap, clamp to the current growth limit and let the heap release non growth limit capacity. We can go inside of this, but I think we should focus only on how the process works. Then at this point we have now application app. And now here, if the app is being launched for full backup or restore, bring it up in a restricted environment with the base application class. This, then they are doing some autofill capture options. Then they are also giving this reference to the init application. Then don't do this after provider, since instrumentation tests generally start their test thread at this point. We don't want that tracing. Yeah, I have a feeling it's specific to the testing. And instrumentation dot on call application on create, this one is called, in this case is isolated. We are getting this again, the information, what will happen here at this point. So who is calling this method handle message and bind application. So I need to figure it out who is using this bind applications. So we are activity thread, again the same class is sending this message, and it look like bind application. So there is one more method who is sending this method to this, like okay we are ready, okay, and we have some information which is interesting. So process name, app info, providers, everything we are updating here at this point, and this method is called bind application. There are too many arguments. Test code to make sure app could see passed in services. Okay, again nice comment, test code. And CB about the following exemption. Okay, now we can check who is calling this. So bind application, no one knows. So bind application in activity thread class. Yes, in activity thread class. So there it is. And who is calling this? So we found there are oh, activity manager service, I application thread, and I application thread. We can check both one by one. So first I think we can check. So I don't know, is it a valid code or is it the dot intermediate frameworks base framework minus apex? Not sure. It looked like it's build generated code. And what about the other one which we saw? This one is also looks like it's the same, but we can check what is going on here. Who is calling this? Attach application locked. Find the application record that is being attached either via the PID if we are running in multiple processes, or just pull the next app record if we are emulating process. So, and this one is a private method, but we can see what is going on. Process record, that this one we saw in a context API, I think so, in observer pattern. How Android OS registering the broadcast receiver. So if you guys remember, in that video we saw this process record, then PID, then they are getting this information process record. What they are doing after this, app is null, then they are putting app null. Can I get this code? This one is generated again. It's is this available in? Oh, that one is available here also as well. But this one is not generated. This one is a com.android.server.am, and in this case package name is this one. Package name is this one is same, but what is the method name we are looking for? Attach application locked. Attach application is locked. And this one is a private method. Who is calling this method? Attach application. And who is calling this method? Invalid application interface. Okay, otherwise it's getting the PID, calling UID, origin ID, attach application logged. So I think we are pretty near what we are looking for. Activity manager service. So root window container, activity manager service. And who is calling this? Why it's not showing? What happened? Can I check this method? So I think it's not showing who is calling this method. But what I can do to make sure. Okay, no, I'm not looking for the history, no references. So in root window. This is going somewhere else. Get top resume activity. So if coming back to this, so I think we can summarize. We started from here. It's going activity thread manager service. It's in bind application is called pretty late. Before that we have a system main method, Zygote main method. Then the loaded APK is in between and responsible to save the information. Then system server is the one who started the application. And what type of methods we saw here in the case of run, this one I think we found, which is called, and that do a lot of things. Create system context, instrumentation, I think it's parallel running with our application. So today we try to understand. I'm not sure if I make more confused, but I hope it's it's good, and I really enjoyed every time when I try to figure it out how things are working under the hood. See you in the next video. Bye.